Hey, pre-algebra students, and welcome to the final concept that we are studying in our proportional reasoning unit, and it has to do with changes. A lot of changes been happening recently, okay? Um, and we're going to use our proportional reasoning to determine are they a big change or a little change. We're going to measure the size of the change, okay? So here's what I want you to do. I want you to pause the video and think of these four scenarios. A cost of a pack of gum went up $1 to $1.50. The cost of a pair of shoes went from $50 up to $70, and the cost of a new car went from $1,800 to $25,000. And D says the number of students at NC State rose by 65. So I want you to stop and think about, okay, is this a big change or a little change, or what is the biggest change here on the warm-up? And interestingly enough, proportionally, not talking about the difference, but proportionally, the first one here, A, is actually the largest change. We're going to talk about why. The cost of a pack of gum going up to $1.50. Okay? Excuse me, the cost of a pack of gum went up a full dollar on an old price of $1.50. And we're going to talk about why coming up soon. Okay? So percentages can also be very, very useful, not only measuring percent of a part of a whole, but also to measure a change, a increase or a decrease. So in the real world, a change, a percent of increase or decrease, is often described using a percentages like we've been studying recently. This helps to better evaluate the amount of change that has taken place. Okay, so where do you see these? In business, you're at a business meeting, it says sales increased by 12% this quarter. Okay, what does that mean? Shopping, cars are discounted at 25% and going fast. Economics, inflation is hovering around 2.3%. What could that mean? I might have to bring in some of your world geography knowledge. And if you hear on sports, and this is sadly not true right now, so the NBA is shut down. But the Warriors are scoring 25% more with Steph Curry back on the court. That's, I guess, not true. That's happening in imaginary land. Okay, so a percent of increase and decrease. What and how? Well, okay, so this is how a percent increase or decrease is going to have to go down. We're going to write a proportion relative to 100, and it is going to become the percent increase or decrease over 100. That is the percent up or down, the change, if you will, the percent change is equal to the change, the actual number, over the original. The amount of change that has taken place over the original number. So the original number is serving as your whole, and the change is the serving as your part, if you want to make a connection to what we did last week. Let's get an example to see if we can make sense of it. Okay, Hunter wants to buy a new tennis racket. The sports store is having a sale on tennis rackets, and the racket she likes costs $49.95. The store is offering a 10% off of the original price. You see this all the time, 10% off. How much will she save is the first question, okay? So these pull tabs that I have on this program are not going to work, but I'm going to draw out what it would say. Okay, let's set up that proportion. Remember, it's going to go something like this. Something relative to 100 is equal to, let's say it again, the change over the original. And let's make that in the context of this problem, the change over the original. Okay, what are we looking for? And what do we know? All right, we know that she is going to get 10% off. So that is $10 out of every $100 that she would spend at this particular sports store gets taken off. So that's a drop of 10. And I like to use the arrows to go up or down in the organization of my work just to show that it is a decrease, right? And my change in actual money will be a decrease as well. And that's what the first question is asking. How much will she save? Okay, so what is the original price? The original price was $49. $49.95. $49.95, and we are looking for how much money she will be taking off, okay? So essentially what is happening here is we are taking 10% of $49.95, and you can solve for x using a cross product equation, okay? Or just find 10% of $49.95, which you could probably do mentally, to find that the decrease is going to be our solution for x here, or $4.99.5, which we'll just call $4.99 for all intensive purposes right now. Actually, let's just round it up. Let's round it up. If x is going to be, since everything goes to the nearest penny, x is going to be $5. Okay, x is going to be $5. So that means she's going to get $5 off of the cost of her racket. And here's the question: what is going to be the new cost? Does that mean she's going to have to pay $5? No, she's going to have to subtract $5 from the original cost. And the sales clerk at the store, imagine going to actual stores, the sales clerk would say the cost is, excuse me, bad math, mental math, is going to be $49.95. Take away the $5. That represents 10%. And the new cost is going to be $44.95. Okay, so there's one example. Let's do another one. Okay, that was an example of a discount already if you take 10% off of something. Okay, another example of a discount here, which would be amount of decrease in price, is this. There's a 15% sale on all jeans at H&M, meaning that all jeans are 15% off. Okay, so why do stores do this? Why don't stores just say take $10 off? Okay, and hopefully you're understanding that not all jeans at H&M cost the same. Right? There could be $100 pair of jeans. I don't think that exists at H&M, but you could correct me if I'm wrong. There could be a $100 pair of jeans. There could be a $40 pair of jeans. So if you're taking 15% off of 100, that would be saving you $15. Okay? But taking you 15% of $40 is going to cost you, it's going to take $6 off. So the amount of savings is proportional. The amount of savings is proportional to the original cost, right? Because it wouldn't make any sense. Let's say if there was a $15 item, and you got $15 off. Okay, then that item would be completely free. The amount of savings is proportional. And that's what the usefulness of a discount in a percentage increase or decrease is. Another word that you'll probably have to know is markup. Okay, so for example, it costs Apple $40 to manufacture the Apple TV system. Okay, there is a 300% markup on this cost to the consumer. Okay, the Apple TV device then sells in stores for $160. Let's actually work that out. Let's actually work out that problem. Pause the recording to do so. Okay, so once again, we said that markup was the increase of money that the manufacturer is going to add to the sales price so that it can make a profit. So in this case, if it increases 300%, that's 300 relative to every 100, that means that the increase in cost here is going to be 100x is equal to 40 times 300, which is 12,000, and we're going to divide that by 100. Solving my cross product equation, of course, to find that x is equal to an increase of $120. So that means that's the markup. That's how much they're going to have to add to the cost. So the increase in cost is 120, making the new sales price 160. Let's get another example. If we recall the percent change formula, to calculate things like the percent of and discount and markup, right? Sometimes you're going to have to take the new amount and subtract the original. You're going to have to take the new amount and subtract the original to find the amount of change that has taken place. Sometimes you might have to find the original amount by taking the new amount and subtracting the amount changed. Sorry for the glitch in the video. It got kind of interrupted by a household emergency, but we're back. All right, so recalling the percent change formula, the percent of change is calculated by the amount that has taken place, of change that has taken place over the original. Remember, that's the new amount, take away the original. And then if you find the original amount, sometimes you're going to have to take the new and subtract the amount that has taken place of change. Let's get an example. All right, the graduating class that was 180 has since decreased to 140. What was the percent of decrease? Let's plug it into the formula. Okay. The percent of decrease is what we are looking for. That is going to be our X or our N. Okay. And let's think about, okay, which of these numbers is the original? Which is the old number? And it says the graduating class size that was 180 has now decreased to 140. What was the percent of decrease? Okay, the original here is 180. But what number is the percent of, or sorry, the amount of change that has taken place? What is the amount of change that has taken place in the problem? All right, and it is not this 140. It is the difference between these two numbers. The amount of change that has taken place is 40. It went down by 40 people, this graduating class did. So that means we are measuring the change of 40 on an original of 140. The common misconception in this problem is to put the 140 on top, but remember that that is not the change. So let's figure out when we solve for n, what is 40%? Sorry, what is a change of 40? What is a change of 40 relative to 180? And this one is not a pretty one. This one works out to, if you solve that proportion, a change of 22.2 repeating percent drop. So the heads of the school or whatever could say that our graduating class size has dropped 22%. Approximately, of course. What about this? The cost of a flight to Miami was $230, but now has increased to $250. What was the percent of change? What was the percent of increase? Okay, so this one's like the other one, but we are finding the percent of increase, not decrease. Okay, so the percent of increase is equal to the amount that it is increased, the amount, AMT, you're going to write that a lot, amount increase on the original. The original always goes on the bottom. So which of these numbers is now the original? Which is the old number? The old number in this case is the 230, the cheaper cost. It used to be 230. Now it has increased, but how much has it increased? It has increased a full, hopefully you can mental math that, it has increased $20. It went up 20, and we are going to measure a change of 20 on an original of 230. So let's go ahead and find out what is 20 out of 230. And that is about a 8.7% increase, rounding to the 10th place, 8.7%. Once again, cross multiply and divide. Remember, a cross product equation will work. I'm also sure that you guys have a few other tools up your tricks to a few other tricks up your sleeve and tools in your belt to be able to solve those percentage problems. Okay, let's do one where we find the new number. Okay, and this says Seth's Bike Hacks had 300K subscribers on YouTube in 2016, but that number increased 80% this year. How many subscribers does the channel have now? I don't know what this is doing down here. I think that was supposed to be gotten rid of. Okay, 300,000 subscribers on YouTube in 2016, and that number increased 80% this year. How many subscribers does he have now? Okay, so we know that 80% increase has occurred relative to 100, and that equals what number of increase on the original 300,000, which we'll just put the K there, because since we're talking about proportions, as long as I do the same to my top number, that should be a viable way to go about this. Okay, so remember, it is not 80% of 100. It is 80% of the 300,000 that is there. Okay, so in this case, we are figuring out what is 80% of 300,000, and that means the increase in subscribers has been 240,000. Now, is that what the problem is asking for, though? How many subscribers does the channel have now? Okay, well, this is not the new number. The new number is going to be the sum of these two. So if it was 300,000 and it went up 240,000, it is now at a cool 540,000 subscribers. Okay, so sometimes to answer the question, you might have to add them both back together, the increase onto the original, right? In this example, Nike shoes that regularly sell for $85.99 are now on sale for 20% off. Calculate the discount and then find the new price of the shoes. Go ahead, do this one on your own, and let's see if we get the same answer. Okay, so in this Nike shoes problem, we have to find 20% of $85.99, and that is the amount of discount, the amount of change that has taken place on the price of the original shoes. And that price, the follow-up question says, how would you find the new price of the shoes? Well, that discount takes place from gets taken off, gets subtracted from the original price. So $85.99, take away the $17.20. Go ahead and throw that through the calculator. $85.99. Take away $17.20. That's rounded to the nearest penny, by the way. The $17.20 is, and it comes out to $68.79 would be the new price of the shoes. Okay. How about this one? Under Armour stock dropped $15 this past year. That's a loss of 46%. What was it worth before this year? So in this practice example, you're finding the original amount. Go ahead and give this one a try. So that does mean pause the video and let's see if we get the same answer. Okay, and we're back. All right, so hopefully you put the 46 over 100, and then you put the change, the $15 over X, the original, and when you solve that proportion, okay, you find that using your cross product equation, X came out to about $32.61, and that was the original cost of that stock, or value of the stock, meaning that is now down $15 from that. Okay, this is the last one that we're going to do on your own. You'll check your answer. So practice this one. In 2014, Cam Newton scored 18 touchdowns, and then in 2015, he has scored 35. What was his percent of increase? Give that one a try now. Okay, so I bet I'm going to hypothesize that this one was the first one that tripped a lot of people up. First of all, remember, the change always goes over the original. So you have to ask yourself, are either of these two numbers the change? Okay, the amount of touchdowns better that Cam Newton has done. And the answer is no. This number is the old number, and this number is the new number. The 35 is the new amount of touchdowns. So to find the change, we're going to have to do a quick subtraction of the two, right? To find that he has gotten 17 touchdowns better this year than he was last year. In 2015 this is. Okay, 2015 he was 17 touchdowns better than he was in 2014. Okay. Now, which of these is the original number? The original number, of course, is the old number, the original in 2014. So this is an increase of 17 with respect to an old number of 18, which he's almost doubling. He is almost doubling his touchdown proficiency in this particular case. So x, when we solve for this cross product equation, we're going to have 1700 divided by 18 comes out to 94.4% better of a touchdown thrower. So that is a 94.4% increase. Okay, so as you're working through the practice assignment today, make sure you take care of looking at, is this number the change? Is it the original? Or is this number a new number? Okay, so you might have to do some subtraction to find those. Take care. Let me know if you have any questions, and enjoy the rest of your day.